So in this video, we've got dx over x squared minus 100. First thought might be a u sub, but we would need an x in the numerator. Integration by parts might be a bit tricky. Trig sub may not be necessary, although we could do one. What I noticed about this one is the denominator factor. So before I do anything, I'm going to try factoring the denominator. So I get dx over x minus 10 times x plus 10. And let's approach this with partial fraction decomposition, see if we can get something easier to find the antiderivative of. So partial fraction decomposition says we would like to write this as a over x minus 10 plus b over x plus 10 dx. And now we need to set up our system. Well, what we do is we just take a look at the numerators. So I'm going to pull out the numerators, and if I were to put this back together, I'd have a times x plus 10 to get the common denominator, plus b times x minus 10 to get the common denominator on this fraction. Now that's the numerator, and the original numerator was just 1, and so that basically builds my system. So we need to find what a and b are going to be, and let me show you a couple different. Let me show you one way, and in other videos I'll do other ways, so you can get kind of a variety. I can multiply through. I get ax plus, let's write it as 10a instead of a10, plus bx minus 10b equals 1. Now what I like to do, one way of doing this is I like to group them. So the x's, there's an ax and a bx, so a plus b, but there were no x's on this side. I want a plus b to equal 0. Now for the constants, I have 10a minus 10b. So for the constants, or sometimes I like to write x to the 0, I have 10a minus 10b has to equal 1, because we want the constants to come out to 1. So there is our system of equations. This one works out real nice because b equals negative a, or a equals negative b, depending on how you want to do it. So we get 10a plus 10a equals 1, or 20a equals 1, a equals 1/20th, which means b equals negative 1/20th. So, putting this together, we get the integral, and we can write these separate if you want to see them nice and clean. 1/20th times 1 over x minus 10 dx minus 1/20th times 1 over x plus 10 dx. Couple of easy antiderivatives. We're going to have 1/20th ln of the absolute value of x minus 10 minus 1/20th ln absolute value of x plus 10 plus c. If you want, you could actually use properties of logs to rewrite this. You get 1/20th ln of the absolute value of x minus 10 over x plus 10, using factoring out the 1/20th and using the subtraction properties of logs. But this would be fine for a final answer. Sometimes when you look in a solutions manual, you'll see it written like this.